Alright guys, in this video we're going to go over how to do magnetically coupled inductors in LT Spice. So if you hit F2 or you go to the component selector, I already have it loaded up here, but note that there are two different types of inductors here, right? Inductor IND and another inductor IND2, which includes the dot. If we want to do inductor coupling, we need to use this inductor 2, which includes the dot, okay? Because if we don't include the dot, then the polarity of the voltage is not going to be known, and LT Spice will have problems solving it. Okay, so I'm going to just put these two inductors here, L1 and L2, and then let's just connect some circuitry here. All right, let's just go with a voltage source. Obviously I need to ground at least one side of this, or LT Spice isn't going to be happy with me. So I'll go to sine 0. We'll just go 1 volt amplitude, and let's just go with 10 kilohertz. Okay, and then I'll throw some series resistance in here. Just make it something small, like 1 milliohm. Okay, just to give me something in series with the inductor. And then let's make these two inductors the same size to start. Let's just call them both 100 microhenries. So that's a 1-to-1 inductor ratio, basically a 1-to-1 turns ratio. And so we should see the same voltage across the primary and the secondary. Let's also put a load resistance here. Let's just say 10 ohms. Why not? And then let's label this V primary, and then we'll call this V secondary plus, or V secondary P, and then we'll call this V secondary minus, so that we can probe the difference between those 2 points and see if it's equal to the voltage across my primary. So right now, if I run this circuit, nothing's going to happen over here. So I can say, let's do just a tran for, I don't know, let's say half a millisecond, so we get 5 cycles. We'll just run that. And let's take a look at my primary signal. So I've got 1 volt peak to peak, or 2 volts peak to peak, basically 1 volt amplitude. If I check the voltage across my primary or my secondary, I have nothing, right? There's no coupling going on here. I basically have to tell LT Spice that I want to perform coupling between these two inductors, and right now I'm not doing that. This is just a circuit with no supply and nothing's happening. So if I hit Spice and I say K, that's my coupling coefficient, I tell it which inductors I want to couple. I basically want to couple inductor 1 to inductor 2, and that's based on the name of the inductors, right? It's L1 and L2. So if I called this something else like L17 or LR, that's the value that you would need to put into this statement. Okay, so K, L1 to L2, and then the value of the coupling coefficient. Remember, this can be a value between 0 and 1. If I want perfect coupling, I'm going to use a value of 1. So let's just do 1 for now. And remember, you can determine the coupling coefficient from the mutual inductance, which is something that we saw in the lecture material. Now these are coupled. Now I can run, and now look what I get. So I'll add the plot, and I see that the primary voltage and the secondary voltage are equal, right? The voltage across the secondary here is exactly equal to the voltage across the primary. And that's because I am coupling these two inductors, and the inductors are the same size, right? So if I make this inductor, because it's the turns ratio is related to the square root, I actually have to take the ratio and square it. So if I want this voltage to be, let's say, 3 times larger than my input, I would need 9 times the inductance. So let's go ahead and make this 900 microhenries, and I should see a 3 volt max, or 3 volt amplitude for this secondary signal now when I run this. And there it is. So take a look at the secondary voltage. Now it swings up to 3 and down to -3, and that's all just a matter of me changing the turns ratio by basically changing the ratio of the inductances, okay? And so if I wanted it to be 5 times larger, I would have to do 5 squared, which would be 2.5 millihenries or 2,500 microhenries. If I do that, I go up to 5 volts and down to minus 5 volts on my secondary. And so this is coupled inductors in LT Spice, magnetically coupled inductors. If you have any questions, let me know. I'm going to go ahead and end this video here. And in the next video, we're going to do a quick example, one of the example problems that we solved, but we're just going to verify our result in LT Spice.